China's lunar probe has found traces of water in samples of the moon's soil. The Chang'e 5 rover completed its mission in 2020, returning to planet Earth with rock and soil samples from the moon.
The moon, once seen as a barren rock, now holds the promise of resources and even life. Could this be humanity's next home? 1. Water on the moon. In a discovery that's shaking up our understanding of the moon, the Earth, and the universe itself. China's Chang'e 5 mission has found something that has shocked us all. This unexpected discovery in the lunar soil may just have proven that aliens exist. Chinese scientists have found water on the moon. We're talking actual H2O molecules, and they're trapped within the crystal structures of rocks brought back from the lunar surface. This is a significant discovery. For decades, scientists believed the moon was bone dry, based on samples returned from the Apollo missions. But in recent years, remote sensing from lunar orbiters has been pointing us towards the possibility of water, particularly in the permanently shadowed craters near the moon's poles. Chang'e 5, however, landed in a sunlit region and still found water, suggesting it's more widespread than previously thought. This water, although locked within minerals, could be a game changer for future lunar exploration. 2. And there's ammonia. The discoveries from Chang'e 5 continue to unfold. Alongside water, scientists were surprised to find ammonia tucked away within the same lunar rock samples. While ammonia might not seem as immediately exciting as water, its presence on the moon has significant implications. Ammonia is a key ingredient in the production of rocket fuel. If extraction on the moon is possible, it could drastically cut down the cost and complexity of future space missions. Ammonia isn't just useful for rockets. It could also play a super important role in supporting future lunar settlements. We're talking about using it to create fertilizers for growing food and even incorporating it into life support systems. 3. Lunar Agriculture. In order to establish permanent bases on the moon, there needs to be a reliable food source. Scientists are already working on making lunar agriculture a reality. They're working on making lunar agriculture a reality. Recent research shows that bacteria can be used to enrich lunar soil, also known as regolith, making it more hospitable for plant growth. In lab experiments, scientists successfully grew tobacco plants in simulated lunar soil treated with these helpful bacteria. The treated plants had longer stems and roots, along with heavier and wider leaves, compared to those grown in untreated soil. This breakthrough could truly pave the way for future lunar life by helping us utilize lunar greenhouses, which provide sustainable ways to grow food and generate oxygen for lunar inhabitants. While challenges remain, like protecting crops from harsh lunar conditions and optimizing growth systems, the possibility of lunar agriculture brings us one step closer to a self-sufficient human presence on the moon. 4. Lunar Energy. The moon isn't just a source of potential water and minerals, it could also offer us clean energy. One concept, still in its early stages, involves mining helium-3, or He3, from the moon's surface. This rare isotope is a potential fuel for nuclear fusion, a process that could generate vast amounts of energy without the harmful byproducts of traditional nuclear fission. Forget reliance on natural gases, this could be the future. Scientists estimate that the moon's regolith growth contains enough He3 to power the entire plant for thousands of years. But extracting He3 is no easy feat. It involves heating lunar soil to extreme temperatures and developing fusion reactors on a massive scale tech that just doesn't exist yet. Despite these hurdles, the potential of He3 is far too great to ignore. It could offer a clean, virtually limitless energy source, completely revolutionizing how we power our civilization. 5. The moon's harsh reality. The moon may hold promise, but it's no walk in the park. With no atmosphere to protect it, the surface experiences wild temperature swings, going from a scorching 250 degrees Fahrenheit in the sun to a sub-zero minus 208 degrees Fahrenheit in the shade. There's no in-between. Add to that the constant bombardment of solar radiation and micrometeorites, and the lunar environment becomes exceedingly challenging for human habitation. Living on the moon would mean creating airtight habitats, shielding ourselves from radiation, and finding ways to grow food in lunar soil, which is this dusty, abrasive substance that could destroy our lungs and any equipment we choose to take with us. And let's not forget the long-term effects of low gravity on the human body. We're still figuring those out. The moon's potential is vast, but the challenges are real. Significant technological and logistical obstacles must be overcome before establishing a permanent human presence on its surface. To gain perspective on the current state of lunar exploration, revisiting humanity's first steps on the moon is essential. 6. The first steps. Humanity's initial foray onto the moon.
Small step for man, one giant leap for mankind.
The dream of reaching the moon has captivated humanity for centuries, but it wasn't until the mid-20th century that it became a reality. The space race, a fierce competition between the United States and the Soviet Union, fueled remarkable advancements in space technology. The culmination of this race was the historic Apollo 11 mission in 1969. On July 20th of that year, Neil Armstrong and Buzz Aldrin became the first humans to set foot on the lunar surface, taking one small step for a man, one giant leap for mankind. The Apollo missions, which continued until 1972, saw a total of 12 astronauts walk on the moon, conducting scientific experiments, collecting samples, and capturing iconic images that continue to inspire awe and wonder. While the Apollo missions were a remarkable achievement, they marked the end of an era in lunar exploration. For decades, the moon remained largely untouched, but recent discoveries, like those from China's Chang'e 5 mission, have reignited interest in our celestial neighbor, sparking a new space race with both national and commercial players vying for a foothold on the lunar surface. But before we delve into this exciting new chapter, let's explore the legal framework that governs our activities on the moon. 7. The Outer Space Treaty, 1967, the foundation of space law. The Outer Space Treaty, signed in 1967 at the height of the Cold War, serves as the bedrock of international space law. Born out of a desire to prevent the militarization of space and ensure its peaceful exploration. This treaty sets up some of key principles that guide us on how nations should conduct themselves beyond Earth's atmosphere. Fundamentally, the treaty declares that space, including the moon and other celestial bodies, is the province of all mankind and should be used for the benefit and in the interests of all countries. It prohibits any nation from claiming sovereignty over any part of space, effectively preventing a land grab on the moon or other planets. The treaty also emphasizes the peaceful use of space, forbidding the placement of nuclear weapons or other weapons of mass destruction in orbit or on celestial bodies. It encourages the free exploration and use of space for scientific purposes, promoting international cooperation and the sharing of knowledge gained from space exploration. While the treaty provides a broad framework for space activities, it leaves a lot of questions unanswered, particularly when it comes to the commercial exploitation of space resources. As technology advances and the prospect of lunar mining becomes more and more realistic, there's a growing need for further clarification and international agreements on how to responsibly manage and share the benefits of these resources. 8. The Moon Agreement, 1979, an idealistic vision. The Moon Agreement of 1979 is a follow-up to the Outer Space Treaty that paints a somewhat idealistic vision for lunar activity. It declares the moon and its resources the common heritage of mankind, emphasizing that they belong to everyone and should be managed for the benefit of all humanity, not just one developed nation. It even says we should form an international regime to oversee resource exploitation, ensuring a super equitable sharing of benefits once such activities become feasible. However, this agreement faces one major hurdle. A lot of countries actually exploring outer space refuse to sign up for it. This lack of widespread acceptance limits its practical impact and raises questions about its enforceability. One key point of contention is the concept of the moon as a common heritage of mankind. Some worry this principle could hinder commercial resource extraction and development on the moon. This highlights a growing tension. the idealistic vision of shared lunar resources clashes with the practical realities of an increasingly competitive space environment. 9. The Artemis Accords, 2020. A new framework for lunar exploration. In 2020, the United States introduced the Artemis Accords, a set of principles designed to foster cooperation and guide responsible behavior as we return to the Moon. These accords reaffirm a commitment to peaceful lunar activities, promote transparency and data sharing, and ensure that astronauts receive help in emergencies, no matter where they're from. But the Artemis Accords aren't without controversy. They also support the extraction and use of lunar resources, something some nations see as conflicting with the idea that the Moon belongs to everyone. This has sparked debate, with some even suggesting the US is trying to lay claim to the Moon's riches. While a number of countries have signed on, some major players like Russia and China haven't. This shows that the conversation about who gets to do what on the Moon is far from over. As we head back to the lunar surface, the question of how we'll govern and manage our activities there is becoming more urgent than ever. 10. The new space race.
It's a new day in space exploration. As we sail on this new cosmic sea, there's so much to learn. There's so much to be excited about.
The United States, with its Artemis program, wants to send people up to the Moon by 2025 and make them stay there for good. They're planning to build a moon base that relies solely on resources from the Moon itself, and they want to work with lots of other countries to make it all happen. Russia, on the other hand, though once a pioneer in space, is facing some serious challenges keeping up these days. That doesn't mean the nation doesn't have plans to go back to the Moon. Russian scientists are actively working on the International Space Station to solidify their place in the space race. It's no longer just the US and Russia battling for supremacy anymore either. China, India, and even private companies are all staking their claim in this new lunar frontier. 11. India's Chandrayaan program. India has also made remarkable strides in lunar exploration with its Chandrayaan program. Chandrayaan-1, a satellite launched in 2008, made some crazy discoveries about the presence of water molecules on the lunar surface. While Chandrayaan-2 faced a setback with its lander, the recent Chandrayaan-3 mission has created history by successfully soft landing on the Moon's south pole. This makes India the first country to reach this region, which is believed to harbor vast reserves of water ice, a crucial resource for future lunar missions. And then there's China. 12. China's Space Odyssey. Chang'e leads the way. China's lunar ambitions don't end with the Chang'e 5 discovery. Following on the heels of Chang'e 5's success, the Chang'e 6 mission made history in 2024 by becoming the first to retrieve samples from the far side of the Moon. This ambitious mission not only collected valuable lunar material, but also deployed a small rover to explore the surface and conduct scientific experiments. China's lunar program isn't just about collecting rocks and dust, though. There's already an upcoming Chang'e 7 mission that aims to land on the Moon's south pole. This could be a crucial step towards establishing a permanent human presence on the Moon, providing access to a vital resource for life support and potential rocket fuel production. China's ultimate goal is to one day build a lunar research station near the South Pole. This would take the shape of some sort of a collaborative effort with Russia, known as the International Lunar Research Station. This project is already in the works and is expected to be completed as soon as 2030. This could easily pave the way for crewed lunar landings and even a permanent lunar base in the coming decades. 13. Tiangong, China's gateway to the stars. While the Moon remains a tantalizing target, China isn't neglecting its ambitions closer to home. High above Earth, the Tiangong space station orbits as a shining symbol of their technological prowess. This isn't just any space station, it's a modular marvel, equipped with state-of-the-art laboratories and research facilities, making it a bustling hub of scientific discovery. On board Tiangong, Chinese astronauts, or taikonauts, are pushing the boundaries of what's possible in space. They're studying the effects of microgravity on the human body, conducting experiments in materials science and astronomy, and even growing plants in space. These experiments aren't just for show, they're laying the groundwork for future long-duration space missions, including potential trips to Mars. But Tiangong is more than just a science lab. It's also a crucial stepping stone for China's grander space ambitions. The station serves as a test bed for technologies that will be essential for future lunar missions and deep space exploration. Think of it as a training ground for the next generation of Chinese astronauts who will venture further into the cosmos. But China's ambitions don't end in low Earth orbit. They have their sights set on much more distant targets, including the asteroid belt. 14. Tianwen. 2. China's asteroid rendezvous. China's Tianwen-2 mission, set to launch in 2025, marks a significant step forward in their space exploration endeavors. This ambitious mission has its sights set on the near-Earth asteroid 469219 Kamawalewa, a fascinating object that could hold clues to the early formation of our solar system. Tianwen-2 will not simply observe the asteroid from afar, it's designed to get up close and personal. The mission involves an orbiter that will study the asteroid's composition and structure from orbit, as well as a lander that will touch down on its surface to collect precious samples. These samples will then be returned to Earth for in-depth analysis, providing scientists with a unique opportunity to study the building blocks of our solar system in their pristine, unaltered state. 15. The Asteroid Deflection Mission. Beyond scientific exploration, China is also demonstrating its commitment to planetary defense. They're planning a mission to deflect a potentially hazardous asteroid, showcasing their technological prowess and their dedication to protecting our planet from cosmic threats. This mission will involve a dual spacecraft approach. One spacecraft will act as an impactor, deliberately colliding with the asteroid to nudge it off course. The second spacecraft will serve as an observer, monitoring the impact and gathering crucial data about the asteroid's composition and the effectiveness of the deflection technique. While the specific target for this mission has not yet been announced, the near-Earth asteroid 2015 XF261, with its close approaches to Earth in the 2030 timeframe, is a potential candidate. This asteroid, measuring approximately 250 meters in diameter, could pose a significant threat if its trajectory were to intersect with Earth's orbit. China's planned deflection mission demonstrates their proactive approach to mitigating such risks and ensuring the safety of our planet. But while China sets its sights on asteroids, the allure of Mars remains strong, drawing the attention of scientists and dreamers alike. 16. Missions to Mars. Since the 1960s, humans have sent dozens of spacecraft to Mars, each one carrying our hopes and dreams of discovery. Early missions, like NASA's Mariner 4 in 1965, were simple flybys, capturing the first close-up images of the red planet and revealing a cratered, seemingly barren landscape. Then, in 1971, the Soviet Union's Mars 3 made history as the first spacecraft to successfully orbit Mars, though its lander only briefly transmitted data before falling silent. 17. Rovers on the Red Planet. The 1990s marked the arrival of rovers, starting with the small but mighty Sojourner, which paved the way for the iconic Spirit and Opportunity. These resilient explorers far outlasted their expected lifespans, beaming back over 100,000 images and providing crucial evidence that Mars once had liquid water on its surface. Today, the Curiosity rover continues this legacy, diligently exploring Gale Crater and uncovering tantalizing clues about Mars's ancient past. Beyond rovers, numerous orbiters and landers have enriched our knowledge of Mars. Orbiters like NASA's Mars Reconnaissance Orbiter and ESA's Mars Express have mapped the planet in stunning detail, revealing evidence of past rivers, glaciers, and even a possible ancient ocean. Landers like NASA's InSight have given us a glimpse into the planet's interior, detecting Marsquakes and offering insights into its internal structure. With these glimpses into Mars's potential past, it's time to take a closer look at the red planet and compare it to Earth. 18. Mars. Earth's analog, a key to understanding our own planet. Mars, the fourth planet from the Sun, is roughly half the size of our home planet, but its land area is roughly equivalent to all of Earth's continents combined. It even has a day that's just a bit longer than ours, clocking in at 24 hours and 40 minutes. Though its gravity is weaker and a year lasts almost twice as long as ours, these similarities make Mars feel strangely familiar, like a distant cousin of Earth. However, the Mars we see today is a stark contrast to its earthly counterpart. It's a cold, dry desert with a thin atmosphere that struggles to retain heat and shield the surface from harmful solar radiation. The soil contains toxic compounds like perchlorate, and temperatures can plummet to -195 degrees Fahrenheit. 19. A window into the past. Yet evidence suggests Mars wasn't always this inhospitable. Billions of years ago, it likely had a thicker atmosphere, flowing rivers, lakes, and possibly even a vast ocean. Geological features such as dried riverbeds, ancient lake beds, and potential shorelines bear witness to this watery past. One particularly intriguing discovery is the presence of methane in the Martian atmosphere. On Earth, methane is primarily produced by living organisms. While other geological processes can also generate methane, its presence on Mars raises important questions. Could Mars have once harbored life? Could it still exist hidden beneath the surface? NASA's Curiosity rover, tirelessly exploring Gale Crater, has been at the forefront of this investigation. Curiosity has repeatedly detected methane on the Martian surface, albeit in fluctuating amounts and only at night. These puzzling observations have led scientists to propose various theories, including the possibility that methane is trapped beneath hardened salt deposits in the Martian soil, released only when temperatures rise. Curiosity's ongoing exploration is just one part of the story. There's so much more to discover on Mars, and the journey is already underway. 20. The future of Mars exploration. The current missions to Mars are just the beginning. Every 26 months, when Earth and Mars align favorably, a new wave of spacecraft embarks on the 6-month journey to the Red Planet. The United Arab Emirates Hope Orbiter is already studying the Martian atmosphere, while China's Tiangong mission is busy at work too. But perhaps the most ambitious mission currently underway is NASA's Perseverance rover. This car-sized explorer is equipped with a suite of cutting-edge instruments designed to search for signs of ancient life in Jezero Crater, a location once home to a vast lake. Perseverance will also test technologies that could help future human explorers survive on Mars, and even collect samples for eventual return to Earth. These robotic missions are paving the way for humanity's next giant leap, sending humans to Mars. NASA is aiming for the 2030s, and their Orion spacecraft, designed to carry astronauts beyond the Moon, is a key part of this plan. But what exactly is China's Tiangong up to on the Red Planet? 21. China's Martian Explorer. Tiangong made history in 2021 as China's first successful mission to Mars. This mission is made up of an orbiter circling the planet, a lander, and the Zhurong rover, named after the Chinese god of fire exploring the surface. The orbiter is packed with tools like cameras and sensors, helping scientists learn about Mars's geology, atmosphere, and magnetic field. The Zhurong rover, a 6-wheeled, solar-powered machine about the size of a golf cart, is equipped with its own set of high-tech instruments to analyze rocks and soil. It's already traveled a distance of over 2 kilometers, sending back pictures and other valuable information. 22. The SpaceX factor. Private companies like SpaceX are also pushing the boundaries. Elon Musk, with his vision of making humanity a multiplanetary species, is developing technology that could one day transport 1 million people to Mars. At the heart of his ambitious plan is Starship, a fully reusable spacecraft currently in development. It's fully designed to carry both crew and cargo to Mars, with a capacity of up to 100 people per trip. Starship's reusability is instrumental in making Mars colonization affordable, considering it dramatically reduces the cost of space travel. Musk's vision of a Martian city seems pretty far-fetched, but SpaceX is actively working towards it. They've already conducted several test flights of Starship prototypes, and they're even planning to launch the first uncrewed missions to Mars within the next few years. The future of space travel is closer than you think. But the critical question remains: would you ever leave life on Earth behind to move to the Moon or even Mars?